Okay, example 5. A group of students test different masses attached to a spring to see how the length of the spring changes with each new mass. Okay, so they've got this spring attached to the ceiling. Okay, so here's my spring, and it's got a little hook on the end, and I could take some masses. You guys know those like copper masses that you use in science class? Maybe brown would be better. All right, they got a little hook on them, and then they're attached to something, and they say like how many grams they weigh. And you can hook on more. Okay. Okay. Anyways, so they put the mass on the spring, and then the spring stretches, right, and it goes down a little bit more. Okay, and then they take a different mass and put it on, and they see how much it stretches every time. Okay. We're going to use this table to create an equation in slope-intercept form that relates the length of the spring to what mass we put on the spring. Okay, so for instance, when I put 4 grams on the spring, it stretches 7 centimeters. When I put 8 grams on, it stretches 10 centimeters. When I put 12 grams on, it stretches 13 centimeters, and so on. Okay, and we want to figure out how long the spring is going to stretch based on how many grams I put on it. So, to find an equation in slope-intercept form, what 2 things do we need?
Your slope and your intercept.
We need the slope, and we need the y-intercept. Based on the information given to me, can I find the slope?
Yeah.
How?
You take your 2 points. What's that called? Slope formula?
Slope formula, right?
Yeah.
Use 2 points, put them into the slope formula. So slope formula was rise over run, so y2 minus y1 over x2 minus x1. And you can choose arbitrarily what points you want those to be. I'll just use the first 2 points. Okay, and I'll put these into my equation. So I've got 10 minus 7 over 8 minus 4. So that's 3 over 4. There we go. Okay, so far I have the slope. Now I need the y-intercept. The y-intercept here would indicate some kind of initial data. Think about the context of the problem. What would the y-intercept mean here? What would it initially tell you about the problem?
That it starts.
Give you a hint. It's when the mass that you're attaching to the spring weighs 0 grams. Or there's no mass on the spring. Let me put it that way. It's the initial length of the spring without any mass attached to it. Okay? That's what B is going to represent. And do we know that from the table? We don't know that, right? We don't have a row here where the mass is 0 and the length is whatever. All right? So we're going to have to find out that length a different way. So I've got an equation. Y equals, I'll put 0.75. We'll use a decimal here. X plus B. I've got this much so far. How can I find that value B? Give you a hint. I have most of my equation, and I have 4 points on that line. What can I do with any of those 4 points?
Put them in for y.
Stick them in the equation. I can't graph it yet because I don't know what B is. Right? I've got 4 points, 4 candidates here that I can put into my equation. It doesn't matter which one I use, they will all tell me the value of B. So let's use the big one. Huh? Why not? So 19 equals 0.75 times 20 plus B. So 0.75 times 20 is how much? 15? plus B. So B is equal to
4.
4. So our whole equation is, I should use the, I've been avoiding the variables because I didn't want to mix up the m's, but now I'll use the real variables. L equals 0.75 m. That m doesn't mean slope, it just means the mass of the weights that you're attaching, plus 4. So, based on that equation, tell me some things about this spring.
It's
The length equals whatever the mass is times 0.75 plus 4.
Okay, so how much the spring stretches is based on this expression, right? You take 0.75 times the mass and add 4. This 0.75 means what in context of the problem?
that it stretches 3/4 as much as the weight is.
Remember, slope represents some kind of rate. So this is how many centimeters it stretches per gram. Right? It stretches 0.75 centimeters every gram that you add. And the 4 would represent the initial length of the spring with no mass on it. Got that? Okay, you'll have a problem in your textbook just like this. So I want to make sure you guys are clear on that.